We're going to do an activity, but before we do an activity, I want us to think of on our own, and this is the idea where you can write it down on a piece of paper, or just think about it. I want you to, for a minute, think about what topography is. You know what topography is?
Yeah.
Topographical map. So think about that for a minute, and then we'll come back and talk a little bit about it. What is topography? Think about it. Are you guys thinking about it? Maybe I should have had you write it down.
No, I'm thinking. We talked about it yesterday in engineering.
Oh, you did?
Yeah.
All
I did a little bit.
All right, well, the first part is supposed to be for you to think on your own, so I was expecting a little silence here. We'll think in groups after you think on your own. All right, the idea is after about a minute, then you can, after you've thought about it on your own, then you can talk to other people about it. So talk to other people what you think topography is. All right, can you guys share out some of the things that you guys might have talked about? Can you guys share out some of the things that you guys talked about?
Areas and surfaces of shapes.
Areas and surfaces and shapes. What else?
Study of leveled surfaces.
Study of leveled surfaces. Okay, well, we're going to move towards that. Anything else?
We were talking about like in terms of like maps and stuff. So like
Maps?
if you had topography of like a piece of land, it would be like how tall something is or how like it goes down to the ground based off of like one level thing.
Yeah. So how tall something is based on a map. Any other ideas? Yeah.
Space and position.
Space and position. All right. So we're going to explore topography, and you guys are going to work in groups. So the idea is that there's a map here, a topography map that has a map of Woodside-ish area. All right. So what I'd like for you to do is to take one of these, I'll pass out these foam boards, but we have foam boards over here that's pretty small. And you have a map, and the map has, it's a topography map that has the heights of things at some sort of levels. And what I'd like for you to do is try to look at the height, and you're going to get toothpicks. And you're going to cut toothpicks. Tried cutting with scissors, but it was hard, so you need wire cutters. And be careful when you cut it. It might hit your eye. So, somebody with glasses, maybe, I don't know. Sorry, I don't have safety knowledge. But the idea is for you to cut your toothpicks. Yeah, thank you. To cut your toothpicks so that it kind of matches the height. So you have to figure out maybe the highest point on your map and the lowest point on your map, and then just have a ratio of how you're going to cut the toothpicks. Okay, and then I want you to stick the toothpicks here. It's ideally you would make a grid for this, and it's not going to be the whole thing. unless you want to try to make it the whole thing. But the point is for you to make a little topography map on this that includes Cañada College in your map. So whether you want that to be in the center or off to the side, that's fine. So you're going to stick your toothpicks here. And then what I'd like you to do after that is to maybe get some Play-Doh and then make little balls and stick it on top so that it kind of shows the height at any particular level.
What is cheese cloth?
Does that make sense?
Yeah.
All right.
What's this? 800.
Tell me what's happening.
Oh, grid.
You're making a grid?
Yeah. Connecting 2 points.
And
This
then
800 and this is 800, and why do we choose this? What's this then?
I don't know. It's a
600? Okay, that's 600.
all right, tell me what you guys doing.
So we're gonna trace along the lines.
Mm-hmm.
So we're gonna place Cañada here, and the highest point is, let's say, 1,000, and we will cut them accordingly.
Okay. You can cut the paper if you want.
Cut it and just place it on top?
If whatever you want. But you should take the paper off when you're done.
Oh yeah. Oh yeah. Or what we can do, we can stick them like that, and then we just take the paper off.
There we go, it's perfectly through, right? Or we can make marks at the top and just trace them down.
I'll figure out what height we need later.
You know if that's a good idea or a bad idea?
No, I mean after we make the grid.
I'm using the toothpick as a ruler.
Oh, that's a decent idea.
Why don't you use a ruler as a ruler?
Because I'm using the ruler as a
Yeah.
ruler, unfortunately.
Unless we break that in half, we have 2 rulers.
What's your approach here?
Oh, we traced that, and then we're gonna place it on here, and then we're just gonna bring the sticks up.
Okay, cool.
Much faster.
Yeah. And you got your safety goggles too. Good job. All right, tell me what you guys did and explain.
So you said to choose out a portion of the map, but our ruler wasn't very good, so we used this to section out a portion, and then created 10 millimeter lines horizontally and vertically, and then did the same on the sheet of paper or the board, so that it would be a 1-to-1 ratio, and then we took the sticks and stuck them in. For the highest point, which was on the section, was 1600, which is right here. We just left it whole, and then for 800 we split it in half. We didn't have a wire cutter, so some of the estimations are a bit off. That came in after we finished. So we estimated most of them, and then we just stuck them into place. And then for Cañada, we stuck a bigger and different color.
Nice. Good. Can you explain what you guys did?
Yes. So first of all, Cañada is here on this like small hill, and we put toothpicks on the lines where it says, like, let's say this is the highest point, 1200, and for 600 we cut a toothpick by half and plugged it in. So and we placed a small Play-Doh balls so it won't poke, and that's it. And we placed the cloth. So this is the highest. This is mountains on Woodside, and this is Cañada here.
Can you lift the cheesecloth up so we see what's underneath? Okay. Okay, cool. Thanks. Yes.
We didn't want to waste time making it to scale, so we represented every 100 by just cutting the toothpick in half. The whole toothpick represents 700. We cut that in half to get 600. We cut that in half to get 400 and 300. We differentiated them by the Play-Doh color. And for 100, we just didn't put a toothpick.
Okay.
We just put Play-Dohs. And these little guys represent our 200 mark.
Okay. Is the Play-Doh going to stay? Like if you tilt this a little bit?
Oh, with some glue it might.
Okay, yeah, so make sure it doesn't move so much.
Okay.
Oh, yeah, no.
It'll stay.
No,
You just have to add a bit more force.
It's like California, earthquake it's all
Oh, right.
Well, if you look at our cheesecloth, our highest point right here is the 800s. This is, I'm not sure if it's referring to more like 80,000 feet or some shit.
Super high, bro. 8,000
Because of the mountains. But then it goes down. You can see the 700s. 700 is more like Cañada right here, like the peak. This is probably like lot 7 at the very top, and then around it, it goes down. It goes down to like 600, and this is more like where the campus area is. And then this is like going down the ramp, exiting the campus. This is like around 500, 400. And then once you get down, further down, it gets leveled out to like ground level, which is like more around 200, 100.
Okay.
And yeah, that's it.
Cool.
So we traced kind of the outline of the topography lines and put the sticks there at different heights that we measured to scale with the heights that we had. So that's like the one toothpick, and then we cut it according to what the height is, with no toothpicks being the lowest point 400. And then just has the toothpicks holding it up to represent the different curves.
Cool. All right.
That's perfect.
All right, explain.
Just high stuff.
High stuff.
Yeah.
I don't know. Like we read the map to determine the height at each point, and then we cut these toothpicks to be a proportional height, so that we could kind of represent the surface.
Okay. Let's come back and try to wrap up what we're doing and what this is all about. And some of those questions that I tried to ask the sheet kind of go towards what we're trying to learn now. Just to let you know where we are, we've finished talking about the vector functions. We learned about velocity and acceleration by taking derivatives, and we talked about motion. And so the posters that are still up on the wall and the last question on your exam was about motion, and that's about integrating vector valued functions. So now we're ready to go into multivariable functions. And whether you realized it or not, the activity that we did today is closely related to multivariable functions. Okay? So that function is going to be defined by 2 variables. And we can technically have functions that are defined by more variables, but for our class, we'll focus more on 2 variable functions. And then we're going to take derivatives of them. And that is going to be called the partial derivatives, also in chapter 14. And then we're going to take integrals of them. And those are called multiple integrals because we're going to be integrating with respect to more than one of those variables. All right, so this is a quick glimpse of what we were doing and what we're about to do compared to the big picture in our classroom. So a quick rundown on the functions that you guys are working on. Functions of 2 variables, R2 to R. Some viewing examples of that are contour maps, they call them. The topography maps that we were just doing. And they also can generalize to more than just things like above sea level. So this one in particular is a wind or temperature map. So it doesn't tell you how high things are, it tells you how high the temperatures are. So the redder parts here are hotter, and then the less red, the cooler they are. Okay, so contour maps is what we were doing. What can you say about, oops, I saw that you saw the sideways map. What can you say about this particular map or this topography? Maximum height's 50. It's 2 little peaks, right? And so there's probably going to be a saddle in the middle, whatever that saddle is. We kind of talked a little bit about saddle. We'll formalize the idea of a saddle here. Francisco? because just by looking at the map over here, it goes 40 and 50 in the A and B spots. But then when you go, that's going on horizontal. But if you look at the map and go vertical, you see that from here you go down to 20. So it looks like you're going to be decreasing. And it stays at 20 along this level. Yeah. Okay, and we'll dig deeper into that as we go along. All right, there's some numerical examples. You guys have to deal with numerical examples in your homework and algebraic examples. But your grade is an example of a function of more than two variables, more than one variable. Your grade is dependent on your homework, your quizzes, the exams, the finals. I used to have journals, but I don't have journals anymore. We have labs. And what was W? W was, I forgot what W was. So a long time ago, the grading scheme was different, but this is a function that takes 6 variables. And then I have a formula. This is the formula that I would have to compute your grades based on this. So things like this, functions of multivariable functions come up in different scenarios, and here's one of them. What are the simple examples? Oh, area. Areas of rectangles are dependent on the base time length times width or base times height. Perimeter. Volumes. Volume is a function of 3 variables usually. And so in calculus 1, what we would do is we dealt with areas and volumes in calculus 1, but what we did was we found a relationship between 2 of the variables, so we ended up just having 1 variable. So now we're going to get the freedom to be able to deal with functions of more than just 1 variable. Let's do this in order. Got the initialization. That's initialized. So the axis in 3 dimensions. All right, so this is the function that we're going to graph. We'll call it, we kind of know it as z is equal to x squared minus y squared. But now let's formally call it f of xy, because z is equal to f of xy. Do we have questions? Let's see who's chatting. Oh, you don't want to? Okay. Yeah. Yeah, it'll pop up. Don't worry. All right, so what we're going to do is we're going to define this function. And what I'm going to do is I'm going to create points. And so this function created points from -4 to 4 in the x and -4 to 4 in the y. And then what it does is just combine a bunch of points. And the output is the z, and it kind of gives you the height. So what this is right now are points that give you the height. And at this juncture, it looks like it's just a bunch of random points. It's hard to imagine what the function would look like as a whole. So what we can think about this is, the way we can think about this is that we can think about this as your topography map with very few points. Okay, and the way a lot of you did it, you went according to the curve of the level. But what I had initially wanted you to do is to draw a grid. Chris, can you lift that up a little bit? To draw a grid, can you tilt it? Is it glued on? Yeah, so the idea is for you guys to draw a grid where you'll have different x and y values, and those are discrete values that give the height and the points. Okay, so this is kind of a rough sketch. Now imagine if we had more points. If we had more points that's plotted, you can kind of start to see the shape of what we're looking at, right? And then let's get even more points going. And because this is a computer program, I could just plug in a whole bunch of points, and then you can kind of see what it actually would look like. And so putting the cheesecloth on top of your work kind of gives the idea that this is actually a surface, right? This is actually a terrain of what you were doing, and your representations of the terrain are just discrete representations of height at a particular point. And those dots that you guys rolled up the little Play-Doh and put it on top, those are like the dots that are represented here, and the cheese. All right. So is that pretty deep? All right. So what I want you to do is that in your completed artwork, I want you to write your names on it. Maybe I should have had you do this first. Write your names on these things, and I want you to submit it in a box. So as you go out of this building, building 23, you go out to the walkway, the quad or whatever, you'll see a screen on your left side, right? Advertisements and stuff happening on that screen. There's a box on the ground. It says Math 253 Topography Maps or something like that. I want you to carefully lay your project on there. And then I want you to look up. Drop your work, step back a little bit and look up. All right, that's it.